Okay, so let's go to our next example. Example 3. The average drive to work is 9.6 miles. Assume the standard deviation is 1.8 miles. If a random sample of 36 employed people who drive to work are selected, find the probability that the mean of the sample miles driven to work is between 9 and 10 miles. Okay, and so you should try to pause the video and see if you can set up the information. All right. But welcome back for those who actually paused the video. So we know that our population mean. Now notice it didn't give us it didn't state that it's normally distributed, right? But that's okay because our sample size is greater than 30. So we can still find the z-scores, right? Okay. So mu is 9.6. 9 looks crazy. 9.6. Sigma is 1.8. N is 36. And we are trying to figure out the probability that our sample mean is between 9 and 10. All right, so of course I like to draw. So we're going to use the central limit theorem because our sample size is greater than 30. So it will have this normal distribution once we use the central limit theorem and find our z-scores. X1 is 9. X bar, I should say X bar sub 1 is 9. And X bar sub 2 is 10. Okay, so they're each going to be to the left or the right. So we're looking for this area here. Again, Z is equal to X bar minus mu over sigma over the square root of n. Okay, so remember this is the case that's shaded in between two regions. So to find our z-scores, so z sub 1 would be 9 minus 9.6 over 1.8 divided by the square root of 36. Don't forget that because we're using the central limit theorem, because we're talking about sample means, that it's sigma over the square root of n, and I believe you'll get -2, and then z2 is 10 minus 9.6, okay, divided by 1.8 over, I said the square root of 36, we could just put 6, right, is 1.33, okay. So what we have, looking in terms of our z-score, now our mu is 0, z is 0 there as well, and then we have z equals -2, and z equals 1.33. Okay, that's in terms of our z-score, right? And so for looking on your chart, for -2, I believe you'll get 0.0228. And then for 1.33, you'll get 0.9082. Okay, and so the probability between -2 and 1.33 will be 0.9082, right? It's the right minus left minus 0.0228. So it's really, once you just have to see if it's talking about sample means or just directly wanting to know information like in 6.2, but it's very similar to what we've been doing. So this shouldn't be too difficult. And this is 0.8854. And so the question is, what's the probability that the mean of the sample miles driven to work is between 9 and 10 miles? So thus, the probability that the mean of the sample miles will be between 9 and 10 miles is 88.54%. Okay. Given that we take a sample of 36, from that sample of 36 people. Okay. All right. I just didn't have room to write all that. But you should also want to make sure you conclude and answer the question, right? So they wanted to know the probability, right? So make sure you always answer the question. All right, let's look at our last problem. Okay, so here it says the average time spent by construction workers who work on weekends is 7.93 over 2 days. Assume the distribution is approximately normal, okay, and has a standard deviation of 0.8 hours. The first question, those two questions here. A, find the probability that an individual who works at the trade works fewer than 8 hours on the weekend, okay? And B, if a sample of 40 construction workers is randomly selected, find the probability that the mean of the sample will be less than 8 hours, okay? What you should notice here is that problem A, okay, so what you should notice is that the second one is involving the central limit theorem, but A is not. Okay, A is just a problem from 6.2. Okay, so again, you want to make sure you note the difference so you know which formula to use when and where. Okay, because this is talking about, A is talking about an individual. So that's what individual data value. All right. Whereas this is referring to sample, B is referring to sample means. And thus you should think central limit theorem. Okay. All right. So let's answer A. Okay. And again, you should try to see if you can answer it on your own. Well, we know our mean is 7.93. Our standard deviation is 0.8. And for A, we want to know the probability that X is less than 8, right? Because this is an individual data value. That's why it's not X bar. X bar represents a mean, a sample mean. But this is just an individual data value. And so for this, remember, we're just using X minus mu over sigma, okay? So this is 8 minus 7.93 divided by 0.8, which is 0.09. Okay, and so the probability that Z is less than 0.09 is 0.5359. And so the probability that an individual works fewer than 8 hours, okay, so thus the probability that the individual works less than 8 hours is 53.59%. Okay. All right, so that's, again, because we're looking at an individual data value. Now, B is looking at a sample mean. So B is asking for the probability that the mean of the sample is less than 8. Okay, well, we still have the same mu and sigma, right? But now, because we're using our other formula, we have N is 40, which is over 30, right? So we're good. And it also was given to us that it's approximately normal. So we didn't even need to have as many as 40 points since we already given that fact. So now we use Z equals X bar minus mu over sigma divided by the square root of N. Okay. And again, you know, I would allow you a sheet of notes. So you would put this formula on there, but you have to make sure you know when to use the right formula. Okay. So this equals 8 minus 7.93 divided by 0.8, and that's divided by the square root of 40, which is, I believe, 0.5, okay? Or for some reason I have 0.55, so you can let me know if that's wrong. I have different answers, so you can let me know if it's 0.5 or 0.55. Go out 2 places, right? Because your Z chart goes out 2 decimal values. All right, so this is 0.7088. Okay, so the probability that the mean of the sample will be less than 8 hours is 70.88%. Okay, so notice that the difference between the two probabilities, well, for individual, it's 53.6%. For the mean of the sample, it's 70.9%, right? So what's going on is that the sample mean distribution has less, so this distribution over here has less variability than the individual data values, okay? as the n increases, right? And so the standard deviation of the mean decreases, okay? So that's where that difference comes from. Okay, so we are done at 6.3. Start the homework before class on Monday, because if you have any questions, I'll answer those questions before we start 7.1. But if not, we are moving on to 7.1. So make sure you jot down. Well, I'm going to upload the notes for 7.1 before Friday probably. And so you'll have that information as well. Okay, we are done.